Estimating the cost for wiring a modular home involves several factors. Based on the responsibilities outlined, a reasonable estimate for wiring a modular home in New Jersey falls between $4,500 and $6,000. Several factors influence this estimate. Firstly, the size and complexity of the home. Secondly, the number of modular units involved. Thirdly, the accessibility of electrical wiring locations. And fourthly, the prevailing local labor rates and materials costs. Let's break down the responsibilities and provide estimated timeframes for each. Service entrance cable installation and intermodular connections are estimated to take 1 to 2 days. Connecting TV and telephone jack cables typically requires half a day. Circuit completion and intermodular connections are estimated at 2 to 3 days. Installing exterior door lights and other loose items should take around half a day. Running the air conditioner line is another half-day task. The emergency gas shut-off line installation is a quick quarter-day job. Installing the ceiling light line in the crawl space or basement also takes about a quarter of a day. Finally, testing all interior and exterior lights, fans, switches, and outlets is estimated at half a day. Additional considerations come into play. If coordination with heating, ventilation, and air conditioning and gas contractors is needed for line installations, additional time and coordination will be necessary, potentially impacting the final cost. Also, additional charges may apply for any special requirements or unforeseen circumstances that may arise during the project. Here are some tips for charging for your services. Firstly, always get a written estimate approved by the customer before starting any work. This ensures that everyone is on the same page regarding the scope and cost of the project. Secondly, break down the costs by task to provide transparency and allow the customer to understand where their money is going. Thirdly, be prepared to negotiate the final price based on the specific home and your experience. Flexibility and open communication are key to a successful project. To elaborate on the electrical work involved in modular homes, it's essential to understand the general process. Modular homes are constructed in sections, or modules, in a factory setting. These modules are then transported to the building site and assembled on a foundation. Each module typically has its own electrical wiring already installed in the factory, but these systems need to be interconnected once the modules are joined together. The first step is to install the service entrance cable. This cable brings electrical power from the utility company to the main electrical panel of the home. The size and type of the service entrance cable depend on the electrical load of the home, which is determined by factors such as the size of the home, the number of appliances, and the type of heating and cooling system. Local electrical codes, like the National Electrical Code, or NEC, specify the requirements for service entrance cables, including the minimum size of the conductors and the type of insulation. Next, the intermodular wires need to be connected. These are the wires that connect the electrical systems in the different modules of the home. The location of these wires is usually specified in the plans for the home, and they are typically routed through accessible areas such as crawl spaces or attics. The intermodular connections must be made in accordance with local electrical codes. The NEC provides detailed requirements for making electrical connections, including the types of connectors that can be used and the proper methods for insulating and protecting the connections. Once the service entrance cable and intermodular connections are in place, the individual circuits in each module need to be completed. This involves connecting the wires for the lights, outlets, and appliances to the circuit breakers in the electrical panel. The NEC specifies the requirements for wiring circuits, including the size of the wires, the type of outlets and switches that can be used, and the methods for grounding the electrical system. Grounding is an important safety feature that helps to protect against electrical shock. The NEC requires that all electrical systems be properly grounded, and it specifies the methods for doing so. In addition to the basic wiring, there are several other electrical tasks that may need to be performed in a modular home. These include installing exterior door lights, running electrical lines for appliances such as air conditioners and gas furnaces, and installing ceiling lights in crawl spaces or basement. All of these tasks must be performed in accordance with local electrical codes. Before the electrical system is put into service, it must be tested to ensure that it is safe and functioning properly. This typically involves using a multimeter to check the voltage and current in the circuits, as well as testing the ground fault circuit interrupters, or GFCIs, to make sure they are working correctly. GFCIs are special types of outlets that are designed to protect against electrical shock in wet locations such as bathrooms and kitchens. As for the size and complexity of the home, larger homes will naturally require more wiring, more circuits, and more time to complete the electrical work. Similarly, homes with complex layouts or unusual electrical features will also take longer to wire. The number of modular units is another important factor. Each module has its own electrical system, so the more modules there are, the more interconnections that need to be made. This can add significantly to the time and cost of the project. The accessibility of electrical wiring locations can also affect the cost. If the wiring locations are difficult to reach, it will take longer to run the wires and make the connections. This can be a particular problem in older homes or homes with limited crawl space or attic access. Local labor rates and materials costs can also vary significantly from one area to another. In general, labor rates are higher in urban areas than in rural areas, and materials costs can fluctuate depending on supply and demand. Now let's talk about how to prepare an estimate. Providing and installing the service entrance cable to each panel box and connecting all intermodular wires from module to module or to the main panel involves several steps. Firstly, determining the service size based on the home's electrical load is crucial. This involves calculating the total amperage required for all appliances, lighting, and other electrical devices in the home. Secondly, selecting the appropriate cable type and size based on the calculated load and local codes is essential. Underground service entrance or use cable or armored cable may be required depending on the installation. Thirdly, installing the service entrance cable from the utility pole or underground source to the main panel, ensuring proper burial depth and protection from physical damage is necessary. Fourthly, connecting the service entrance cable to the main panel, adhering to all safety precautions and local codes is important. Fifthly, connecting all intermodular wires between the modules, ensuring proper wire size, insulation, and secure connections is vital. Connecting the TV and telephone jack cables that are separately run by the manufacturer to accessible areas for connection involves firstly locating the accessible areas where the manufacturer has run the TV and telephone jack cables. Secondly, connecting the cables to the appropriate jacks or termination points, ensuring secure and reliable connections. Thirdly, testing the connections to verify signal strength and functionality. Completing all circuits and intermodular connections in compliance with local codes, including the main service entrance installation, involves firstly verifying that all wiring meets the requirements of the NEC and local codes. Secondly, completing all circuits by connecting the wires to the appropriate outlets, switches, and appliances. Thirdly, testing all circuits for continuity, proper voltage, and grounding. Fourthly, ensuring that all intermodular connections are properly made and meet code requirements. Installing exterior door lights and interior shipped loose items involves firstly installing the exterior door lights according to the manufacturer's instructions and local codes. Secondly, connecting the lights to the appropriate circuits and testing their functionality. Thirdly, installing any interior shipped loose items such as light fixtures or appliances according to the manufacturer's instructions. Running electric for the air conditioner with the main shut off outside per code involves firstly determining the appropriate circuit size and wire gauge for the air conditioner based on its electrical requirements. Secondly, running a dedicated circuit from the main panel to the air conditioner location. Thirdly, installing a main shut-off switch outside near the air conditioner for emergency or maintenance purposes. Fourthly, connecting the air conditioner to the circuit and testing its functionality. Running a line for the emergency gas shut-off per code involves firstly coordinating with the gas company or a licensed gas technician to determine the appropriate location for the emergency shut-off valve. Secondly, running a dedicated electrical line to the shut-off valve if required for its operation. Thirdly, connecting the line to the valve and testing its functionality. Running a line for ceiling lights in the crawl space or basement per code involves firstly determining the appropriate lighting requirements for the crawl space or basement based on its size and use. Secondly, running electrical lines to the ceiling light locations, ensuring proper wire size and insulation. Thirdly, installing the ceiling lights and connecting them to the circuits. Testing all interior and exterior lights, fans, switches, and outlets involves firstly systematically testing all lights, fans, switches, and outlets in the home to ensure they are functioning properly. Secondly, using a multimeter to check the voltage at each outlet and switch. Thirdly, verifying that all GFCIs are working correctly. Also, consider the additional requirements. Coordinating with heating, ventilation, and air conditioning and gas contractors for line installations, additional time and coordination may be necessary. This includes communicating schedules, coordinating work activities, and ensuring that all installations meet code requirements. Additional charges may apply for any special requirements or unforeseen circumstances. This could include dealing with unexpected wiring issues, working in difficult-to-access areas, or accommodating changes to the original plans. When it comes to charging, firstly, obtain a written estimate that must be approved by the customer before starting work. This protects both parties by clearly outlining the scope of work, the materials to be used, and the total cost of the project. Secondly, breaking down the cost by task to provide transparency allows the customer to see exactly what they are paying for and helps them understand the value of the services being provided. Thirdly, be prepared to negotiate the final price based on the specific home and your experience. Factors such as the complexity of the wiring, the accessibility of the work areas, and the time required to complete the project can all influence the final price. When estimating the cost of wiring a modular home, it is crucial to account for all potential expenses. Firstly, materials account for a significant portion of the overall cost. This includes the cost of wires, cables, outlets, switches, light fixtures, circuit breakers, and other electrical components. The type and quantity of materials required will depend on the size and complexity of the home, as well as the local electrical codes. Secondly, labor costs are another major factor to consider. The hourly rate for electricians can vary depending on their experience, qualifications, and location. The amount of labor required will depend on the scope of work, the accessibility of the work areas, and any unforeseen challenges that may arise. Thirdly, permits and inspections are also necessary. Electrical permits are typically required for any new wiring or modifications to existing wiring. The cost of permits can vary depending on the local municipality. Electrical inspections are also required to ensure that the wiring meets code requirements. Fourthly, equipment rentals may be needed. Depending on the scope of work, it may be necessary to rent specialized equipment such as wire pullers, conduit benders, or trenchers. The cost of equipment rentals can vary depending on the type of equipment and the rental period. Fifthly, insurance is vital. Electricians are required to carry liability insurance to protect themselves and their customers from potential damages or injuries. The cost of insurance can vary depending on the coverage amount and the electrician's risk profile. Sixthly, overhead costs are important. Electricians typically have overhead costs such as office rent, utilities, and advertising. These costs are usually factored into their hourly rate. Seventhly, profit margin is necessary. Electricians need to earn a profit to stay in business and invest in their equipment and training. The profit margin is typically a percentage of the total cost of the project. Some other things to keep in mind is contingency planning, unforeseen issues, change orders, payment schedule, and documentation. Always have a contingency plan in place to address any unforeseen issues that may arise during the project. This could include unexpected wiring problems, changes to the building plans, or delays caused by weather or other factors. Be prepared to handle change orders. Customers may request changes to the original scope of work, which can affect the cost and timeline of the project. Have a clear process in place for documenting and approving change orders. Establish a payment schedule with the customer that outlines when payments will be made. This can help to ensure that you are paid in a timely manner and that the customer is satisfied with the progress of the project. Maintain thorough documentation of all work performed, including wiring diagrams, inspection reports, and change orders. This can be helpful in resolving any disputes that may arise and can also be used for future reference. When working on a modular home, it is important to be aware of the unique challenges and considerations that are involved. Modular homes are constructed in sections in a factory and then transported to the building site for assembly. This means that the electrical wiring must be designed and installed in a way that allows for easy connection between the modules. The electrical connections between the modules must be properly made and inspected to ensure that they are safe and reliable. It is also important to coordinate with the other trades involved in the project, such as the plumbers and HVAC contractors, to ensure that the electrical wiring is properly integrated with the other systems in the home. In addition to the technical aspects of wiring a modular home, it is also important to have strong communication and customer service skills. It is important to communicate clearly with the customer about the scope of work, the timeline, and the cost of the project. It is also important to be responsive to their questions and concerns and to address any issues that may arise in a timely manner. By providing excellent customer service, you can build a strong reputation and generate repeat business.